In my part 2 video, I showed the paddle controller prototype hardware and firmware. I've spent the last few weeks getting it all packaged up into a usable form factor. I fully tested the 3D printed housing, designed some custom PCBs so everything will fit inside, and am done with the final hardware integration. Summer is quickly approaching in Seattle, and I'm trying to get this thing together as fast as I can. In part 2, I showed a little teaser of the 3D printed housing that attaches to the paddle. My engineer/designer friend, Jordan Godoy, created this for me. I've never enjoyed the intricate mechanical designs, but he's always had a love for puzzles and pushing the boundaries on form, function, and size. I couldn't have done this design without him. We grew up doing projects together, getting shocked by disposable cameras, breathing in solder fumes, and failing 9 out of 10 times. It's been awesome working with him all these years later, both of us with new expertise to bring to the table. In the beginning, we started brainstorming how the latching mechanism should work, drawing inspiration from the weightlifting barbell clamps you use when you're squatting. The first design had all the electronics hidden away, integrated into the actual clamping structure. This would have been really cool, but we realized how hard it would be to waterproof. So we ended up settling on a tubular design that sat on top of the clamping mechanism. That way we could waterproof it with a simple O-ring. It was then when I also realized that this was the perfect shape for an LED ring display. From there, Jordan began designing, printing, testing, and iterating. He first experimented with snap fit prints to create strong joints. From there, he tested his first design, but it didn't have enough clamping force. After studying every latching mechanism he could find, came up with a hook clamp design. Once the new clamp proved that it could work, he started tweaking every variable, like hook pitch, adding finger gaps for ease of unclamping, and so on. Last, he came up with a locking shelf that slides in and out of the tube to hold all the electronics in place. This is super important because I need to make sure that the IMU position is consistent every time when I go to train my machine learning models. Once we had a working housing, it was time to test this thing. We had to line the clamping mechanism with some sort of rubber strip to provide a tighter seal on the paddle. Trying a few different materials, foam weatherproofing strips was the answer. This provided enough squish to get the best seal. Now it was time for the big test, waterproofing. I placed 2 O-rings on the lid, installed the push button, and sealed it with some hot glue. I colored stripes onto a paper towel and wadded it up inside the housing. Submerging the whole print in a tub of water, I repeatedly pushed the button, tapped on the housing, and left it submerged for about 20 minutes. To my surprise, pulling out the paper towel, I saw no signs of leaking. Now that the 3D printed housing was ready to go, I needed to shrink all the electronics. We decided to create 2 PCBs, one daughter board that all other breakout boards would mate to, and one new breakout board for the on-off button controller IC. The on-off button controller IC was so small, it was very difficult to hand solder. This is why I decided to create a custom breakout. I'm calling this breakout the Smart Click, but if you can come up with a better name, please leave it in the comments. It allows me to use a single button as a power switch and a regular input button. This enabled the user interface for this project to be super minimal and clean, which I'm all about. If you're interested, I have another video deep diving all the technical details of the SmartClick breakout board. I'm going to open source this design, but let me know in the comments if anyone wants me to put this up on my Tindy store. Huge thanks to PCBway. They really helped make this project possible, sponsoring all the PCBs and 3D prints. They've got super low prices, fast shipping, and you can get a quote in minutes. They support a ton of different makers, so check them out next time you need anything manufactured. After getting my boards and 3D prints from PCBway, I was super excited to get this thing together for the very first time. After a quick fit check, I melted some threaded inserts into the print and secured everything in place. I have the Raspberry Pi talking to the OR electronics. The Pi will eventually be commanding motors and running machine learning models, but for now I just have the Pi logging IMU data to show how the IMU is used for paddle tracking. I'm so close to getting this thing back in the water. I've just got to get the Pi commanding my motors and I'll be ready for my first test of the summer. Make sure to subscribe so you don't miss it.